Hello students, we will start a new topic from Scalars and Vectors. In the last section or in the last video, we discussed about the resolution of vectors, and in that case we resolve the vector into number of components, and mainly we discuss about resolving of a vector into two rectangular components and three rectangular components in coordinate system on a plane in a space. If we are resolving the vector in a plane into two rectangular components along x-axis and y-axis, and we resolve the vector in three rectangular components. And in that discussion, we came to know that always we consider the unit vectors which are rectangular unit vectors or mutually perpendicular unit vectors along x-axis, y-axis, z-axis are denoted as I cap, j cap, k cap along x-axis, y-axis, z-axis respectively. That we discussed in the last video. Now next part we will go for the, so far we have discussed about, or we are very much familiar with the addition and subtraction of vectors. From there, now we will go for another mathematical operation with the vectors, that is the product of vectors. So here we will go for the next is the product of vectors or multiplication of vectors. What is this multiplication or product of vectors means? As you know, if you multiply two vectors, then naturally that should be the multiplication or the product of vectors, isn't it? If you multiply that, then that is the multiplication or a product of vectors. Now, if I want to explain you, when you multiply two scalar quantities, 2 and 3 suppose. So when you are multiplying 2 with 3, then you are doing what? You just do this 2 into 3, it means that like this, or someone can write 2 into 3. This is not written like that. Or suppose your x is a scalar and you multiply with y, so you can put x dot y like that. So you can put the symbols like that. This symbol implies is a product. That means you understand that this is equal to 6, or simply you can write xy. Or you can simply write xy. These are scalars. But in product of vectors, it does not allow us, the product of vectors does not allow us to put the symbols as per our convenience. As per our convenience means it does not allow us. Means suppose if the vector A is there and there is another vector B. If I want to multiply these vectors, or if I want to do the product of these vectors, then if I put a dot, its meaning is different. If I put a cross, its meaning is different. Means the same, if it is the scalar case, both are same thing, this is the multiplication. But here if it is a dot between the two vectors, it is something different. And if it is a cross, the meaning is something different. So that means this product of vectors does not allow us or make us free to put the symbol dot or cross. Dot or cross. So accordingly, if I put a dot between these two vectors, this is called the dot product of vectors. If I put a cross symbol in between them, then this is called the cross product of two vectors. If the vectors are written like this, A, B, without any symbol, if you write like this, it has no meaning in physics. It has no meaning in physics. If I write like this, it has no meaning. You must put a dot or cross in between the two vectors. Then we can say that if it is a dot, then this is a dot product, and if it is a cross, there is a cross product. So now in this product of vectors, first we will go for the first product, that is the dot product of two vectors. Now here we will go for the first one, is the dot product of two vectors. Then we will go for the cross product of two vectors, right? So first we will go for the dot product of two vectors. First we discuss about the dot product of two vectors. Clear? So now, what is this dot product of two vectors? Means when you see there are two vectors are there and a dot symbol is in between them, then you can say that this is the dot product of two vectors. Clear? Now, let us consider two vectors. Let me show that two vectors are like this. A and B are the two vectors. And let theta is the angle between the two vectors. As I joined like this. Right? So, now here you can say that which vector, what is the angle we will consider here? This is the smaller angle. So there is a joining of tail to tail. So one can say this is also an angle between A and B. 360 minus theta. But the angle between the two vectors, as I already told that should always lie between 0 to 180. So remember one thing, the angle between the two vectors means you will consider the smaller angle. The smaller angle, because obviously this is the smaller angle and this one is the larger angle. So I will consider this angle is a theta. Clear? Let us consider the two vectors A and B with an angle, the smaller angle between them is a theta. So the dot product of two vectors is the product of magnitudes of the vectors, product of the magnitude of the two vectors multiplied by cosine, means cosine of smaller angle between them. Multiplied with smaller angle between them. This is called dot product of two vectors. And remember, the dot product of two vectors give us a scalar quantity. The dot product of two vectors gives us a scalar quantity. That's why this dot product of two vectors, or this is also called as a scalar product. Now you see. So this is the definition, or this is the definition, and we can show that the dot product A dot B. So this is the dot product. It is written as A dot B with a symbol. And remember, if there is no symbol, it is no meaning. You should put a dot product and a cross product. We are discussing about dot product, so we are going for dot. So A dot B. This can be written as the dot product of two vectors is the product of magnitudes of the vectors. So write the magnitude of A, simply A, more A or simply A. Then B. Now what these are? Scalars. Magnitudes of the vectors, these are scalars. And multiplied by cosine of which angle? Smaller angle. Which angle is the smaller angle? Theta. Now here see, the result is what? A scalar. This is the magnitude of A, this is the magnitude of B, and cos theta is always a number. So you will get the final result as a number. So we have two vectors and we are making dot product and we are getting a scalar quantity. So that's why it is also called as scalar product. It is also called a scalar product. Why? Because the result of dot product two vectors is a scalar. Because the dot product of two vectors, the result is a scalar. Is that clear? So we can write this. Now we go to this expression again. So again I will write this as A dot B is equal to, one can write this as, now I can write this as A B cos theta is one term. Suppose I take this as A B cos theta. What it means? B cos theta. So now we go to the component forms. I told you this components form is very, very important. So now you take this is a B vector. What is the component of B along this A? If this is a theta, now we go to this expression. This is a vector A. What is the component of A along this direction, which makes an angle theta? Then you go for this like that. So let me draw like this again. A is a vector given. This is one axis x and y, suppose they are perpendicular, and this angle is theta. What is the component of A along this direction? What is the component of A along this direction? A cos theta. And what is the component of A along this direction? They are perpendicular. A sin theta. So I am not going to this part. I have a vector B. What is the component of B along this? Then to this A there is a perpendicular. To this A there must be a perpendicular. To this A there is a perpendicular. So if B is a vector, what is the component of B along this one? B cos theta. B cos theta. The component of B along this one is B cos theta. So what is this B cos theta? You can say. Now we can write this as, I can write this as, this is equal to magnitude of A multiplied. Because these are scalars. Don't bother about this multiplication, all these things. This part is scalar. Magnitude of A multiplied by B cos theta. I can write this as the component of vector B along A. Can you write like this? Component of B along vector A, or component of B along the direction of vector A. In what direction the A? A is in this direction. B cos theta is the component of B along A. This is the another definition. So now the definition we can write this as, from here we can write this as, now let me write the another definition. How we can understand this dot product? Another one we can write. So let me write the another part is the dot product of two vectors. The dot product of two vectors. The dot product of two vectors is, the dot product of two vectors is defined as the product of, but the product of the magnitude of one vector, magnitude of one vector, and the component of the other vector, means there are two vectors. You are taking the magnitude of one vector, then the next vector, that other vector. The component of the other vector along the direction of the first vector, and the component of the other vector along the direction of the first vector, So this is your, you can say this is the A dot B. This is another definition. Now you see here. Again I am repeating that. A dot B is equal to A into B cos theta. This can be written. Suppose the same definition. So magnitude of A, so this is vector A, and component of B along A. Now you can write this as A dot B is equal to, you can write B into A cos theta. This is also true. Because A B cos theta, these are scalars. A scalar, B scalar, cos theta scalar. So you can write like this. So in that part, when you take this, then in this case, if I draw a perpendicular here, this is your B cos theta. This is your B cos theta. Similarly, you can write this as another way. If someone has written like this, then this is the magnitude of B into component of A along B. Let me show this one again. If I show this in the figure, suppose I have this same rotation is that. Suppose I have the vector A and this is the vector B. This is the vector B. So if I draw a component of A along B, then I draw perpendicular here. From here, a perpendicular to this one. So this part is what? Your A cos theta. Why? Because this angle is theta. A is a vector, it is A cos theta. And to this, if I draw another perpendicular like this, to this if I draw perpendicular, what is about this? This is a sin theta. This will be a sin theta. If I show like this component is a sin theta. Understand this one? I already told that this component form is very interesting, and if you do or if you play with this one, that is very easier for you. So this is your a sin theta. We are not bothered about this sin theta because we are getting a cos theta. So what is the component of A along this? Along this A cos theta. So magnitude of B, that is A dot B, and A cos theta, component of A along B. So this is called the dot product of or scalar product of vectors. Now this has a lot of importance in our physical or deal with the physical quantities. So what are the examples we can say? The examples are like that. You may read or you may read in the later stage, in the later discussion. Then you go further in physics discussion. Then you can come across this one. The examples we can say here, where the dot product two vectors. So this dot product for two vectors, or this is also called as the scalar product. Now you can write this as also called as a scalar product. Why? Because the result is a scalar. So I have two vectors. Example is that force is a vector, and this dot product of scalar, that is called displacement. Force dot displacement. The dot product force and displacement will give you what? This is a scalar. So this is the force and this is the displacement. And as you know, both are force, this is the displacement, and force. The dot product two vectors gives you a what? That is the scalar. This is scalar. Clear? That is the example. Means you are multiplying the two vectors and you are getting the result as a scalar. The other examples we can say that the dot product of force with velocity, that will give you power, and power is a scalar. This power is a scalar, and force and velocity, they are vectors. Similarly, we will come across with a flux stop, electric flux. Electric flux, that can be written as like this. Electric flux. Electric flux. For this electric flux, this is a scalar. As there is no vector, so this is a scalar. So this electric flux is the dot product of electric field intensity dot. This is the second we will discuss these things. Electric field intensity and area vector. Area is a vector. Remember, this is the area vector. Area vector, and this is the electric field intensity. Electric field intensity. Okay, so this is the electric flux. So the dot product two vectors is a scalar. So that is my point. Now we go for the properties of dot product or scalar product. Now let me erase this thing. Now come to the properties of scalar product, or that can be called as a dot product. Scalar product or the dot product. Now we will discuss some of the properties. So the first property, number one. So let me give the name like one. First property. Dot product is commutative. Let me write this one. Dot product is commutative. Commutative. Vector addition is commutative, like that. What is this commutative is? Means, by definition, so we can say that A dot B is equal to B dot A. Both are same thing. Why? Because what is this A dot B? This is AB cos theta. If angle between them is theta. This is equal to B dot A. So suppose you write B and cos theta. But what is this? They are scalars. These are magnitude of A, magnitude of B. You can multiply. Suppose magnitude of A is 2, magnitude of B is 3. So 2 into 3 or 3 into 2. Both are same thing. So AB or BA. Both are same thing. So the dot product is, you can say that it is a commutative. Is that clear? The dot product is a commutative. Next, number 2. Second one. Dot product is distributive. Dot product is distributive over, dot product is distributive over the addition of vectors, over addition of vectors. What it means, try to understand. What it means, try to understand. So this implies dot product is distributive over addition of vectors. Means this dot product, if you make a dot product of A dot product, then it should be a symbol dot product of two vectors and they are added something like that, P plus C. And suppose you take this as P like that. This is the addition of vectors. So this dot product of A is distributed with each vector which are added. Means you can write this as A dot B. A is distributed to B. Then as usual plus sign. So I will put this plus. Simply multiplication. But important thing is you have to put the dot symbol. You have to put the dot symbol. So this will give you a scalar. So here you have three. You can write A dot B or B dot A according to rule number 1. Then A dot C. A is distributed to C. Then plus A is distributed to B. A is distributed to D. So this is called as the dot product is distributed over the addition of vectors. Now we go for the third one. The next point is that if we take the dot product of two equal vectors, the dot product of two equal vectors is, dot product of two equal vectors is square of magnitudes, square of magnitude of any one vector. Square of magnitude of any one vector. Now come to here. The dot product two equal vectors. So what it gives you? Now let us consider the vector A and its equal vectors A and B. When they are called equal, both have same magnitude and in the same direction. Means the angle between them is what? 0 degree. Angle between them. Now we put this B over here. This parallel shifted. B is parallel shifted. So same magnitude. So B is equal to A. In place of A, I can write this as B, or in place of B, I can write this as A. That is the equal vectors. Already you know that. So in this discussion, we are not discussing about the equal vectors, but here we are discussing the dot product of equal vectors. So A and A I can write, they are equal, and that is the dot symbol. That is the dot product of equal vectors. Okay. This is equal to, go to your formula, A dot B is equal to AB cos theta. So A dot A means, suppose this is B, suppose magnitude of A. and magnitude of A. This is also, suppose this is a B, the magnitude of the two vectors, and cosine of smaller angle between them. What is the cosine of smaller angle between them? What is the cosine of smaller angle between them? What is the cosine of smaller? A and A, both are in the same direction, 0 degree. Are you getting now? You are getting? Okay. So A dot A cos 0, this is equal to, what is cos 0? 1. So A into A, multiplication of two scalars, 2 into 2, 2 square, 5 into 5, 5 square. So I can write this as A square. So we can write this up, or this is saying that more of A square. This is a scalar, you can write A square. So square of magnitude of any one vector, because that is the square of magnitude of the vectors. Two equal vectors, if you take the dot product like that. But remember, if we go to the I cap, j cap, k cap, now I will play with I cap, j cap, k cap. I cap dot I cap, suppose I find I cap dot I cap. I cap dot I cap. I cap is a unit vector along x-axis, isn't it? I cap is a unit vector along x-axis. J cap is a unit vector along y-axis. K cap is a unit vector along z-axis. And I cap, j cap, k cap are mutually perpendicular to each other, isn't it? So make it by heart. Make it by heart till end. Okay? Now I cap dot I cap. So I cap dot I cap, do the same procedure. Don't get anything more complicated. So I don't like that complication. I want anything, or I make that everything simpler, so that it is very much interesting. So I dot I. So let this is a I cap is a vector, and it is a unit vector along x-axis. Okay. What is a unit vector? A vector whose magnitude is one unit, and it is along the direction of the given vector. So there is a vector along x-axis, and I cap is a unit vector along that x-axis with unit magnitude. Then we are making dot product. What is the magnitude of I cap? 1. We are considering a magnitude. What is the magnitude of another I cap? 1. 1 into 1. Let me put this. In the scalars you can put cross, no problem. Dot cross, there is no problem. So 1 into 1. Then cosine of, what is the angle between I and I? Both are in the x-axis. So 1 into 1 cos 0 is 1. 1. So I cap dot I cap is 1. Similarly, the dot product of 2 equal j cap k 1. K cap k dot k cap 1. Remember, this is very important. I cap dot I cap 1. J cap dot j cap 1. K cap dot k cap 1. Here. So this is the, similarly you can find the third point, the dot product of equal vectors. Now can we go for the fourth one? Are you comfortable to go to the fourth? Okay. So now we go for the fourth one. Now come to the fourth. Are you comfortable now? Yes. Then the dot product two perpendicular vectors. What it is? So the for dot product of two perpendicular. I can use the symbol 2. I already told that I will use some symbols. I will not write everything. Dot product of two perpendicular vectors is 0. Find out this. Two perpendicular vectors. A, B. They are perpendicular. 90. Perpendicular. What is the component of B along A? If they are perpendicular, what is the component of B along A? For the timing you tell me. Component of B along A. So B cos theta. Component of B along A, B cos theta. What is that B cos theta? B cos 90. What is that cos 90? What is cos 90? 0. So this is 0. The component of B along A, 0. Means here we got that this is equal to 0. The perpendicular, remember this one, the perpendicular component of a vector is 0. If a vector is there, its perpendicular component, the perpendicular component of a vector is a 0, right? So here this is the perpendicular component, but this is not my point. Here b cos 90 is equal to 0. So this gives me another idea. So here I will now prove that a dot b dot product 2 and they are perpendicular. So I will write magnitude of a, magnitude of b, cos 90. What is cos 90? 0. So a dot b is equal to 0. A dot b is equal to 0. That means if you take the dot product two vectors and the magnitude, if the dot product two vectors is 0, they must be perpendicular. The two vectors must be perpendicular. So if you go to the second definition, what we are writing there? The product, the dot product two vectors is defined as the magnitude of one vector and the component of the other vector along the direction of that vector. The component of b along the direction of a, that is equal to 0. That is equal to 0. Clear? So that means the component of a vector, the perpendicular component of a vector is a 0. Suppose I will give you a vector like this. Suppose the vector is like this a, and there is a perpendicular component like this. This is 90. So what is the component of a along this direction? A cos 90. Same thing. Don't take this horizontal vertical like that. If this is 90, a cos 90. What is cos 90? 0. So what is the component of this vector a along this? 0. So this component is 0, so that's the result is 0. Means when we are doing the finding the component of a vector along another vector and their component is perpendicular to this vector, the component is perpendicular to this vector, it is 0, so 0 is multiplied, a dot b is equal to 0. So we can write two vectors are perpendicular. Two vectors are perpendicular if their dot product is 0. Is that clear? So this is a condition also. The dot product two vectors is 0, then we can say they are perpendicular to each other. Now in that discussion we will go for unit vectors, perpendicular unit vectors along x-axis ik, y-axis z-axis. So suppose I make I cap dot z. These are the two unit vectors and they are rectangular unit vectors. I cap is along x-axis and j cap is along y-axis. So when I make this I cap dot j cap, go for else of the rule a dot b, ab cos 90, they are perpendicular. Similarly, I cap, what is the magnitude of I cap? 1. Multiplied with, what is the magnitude of j cap? 1. They are unit vectors. That multiplied with cosine of, what is the angle between I and j? That angle is 90. So cos 90, 1 into 1, 1, cos 90, 0. So this result is 0. So I can say that I cap dot j cap is equal to 0. Means the dot product of two rectangular unit vectors, the dot product of two rectangular unit vectors is 0. Then as you know, I cap, j cap, k cap, these three unit vectors are mutually perpendicular to each other and they are considered along x-axis, y-axis, z-axis respectively. So according to that, I can write this I cap, j cap is 0. Then I can, if I do j cap dot k cap. Similarly, what is the angle between z and k? 90. So the result will be 0. Similarly, I will take k dot I cap is 0. Suppose in the same part, I will ask you what is j cap dot I cap? I cap dot j cap equal 0 I have written here, but if I ask you what is j cap dot I cap, what you will say? It is also 0 because as per the rule number 1, as per the first property, that is commutative. If you write I cap I dot j or j dot I cap dot j cap or j cap dot I cap, both are same thing because it is a commutative. So that is the next one. So this is the fourth one. Now we will go to the fifth one. So the fifth, this is the, next we will go for the fifth property. Let's write the fifth one. The dot product two parallel vectors. If I take the dot product of two parallel vectors, dot product two parallel vectors, right? Now we go for the fifth one, dot product of two parallel vectors. What will it? First I will find, then I will write this here. What this will give you? The dot product of two parallel vectors is equal to the product of magnitudes. Product of magnitudes of the vectors is equal to the product of magnitudes of the vectors. Isn't it? Let me write here A dot B. So already know that parallel vector is the magnitude may or may not same, but they are in the same direction. Same direction. Angle between two parallel vectors is 0. So if you do this A dot B, then this is equal to magnitude of A and magnitude of B, cosine of angle between them is 0. So cos 0. So 1 is cos 0 is 1. So this is AB. That I have written here. Dot product two parallel vectors is equal to the product of magnitude of the vectors. Product of the magnitude of the vectors. Clear? Then next we will go for the sixth one. Dot product of two anti-parallel vectors. What it will give you? The dot product of two anti-parallel vectors. Dot product of two anti-parallel vectors. Anti-parallel means what? They may or may not have same magnitude but opposite direction. So the dot product of two anti-parallel vector is negative of the product of magnitudes of the vectors. Now see here anti-parallel means what? Theta is 0 for parallel, anti-parallel theta is equal to 180 degrees. Right? Then A dot B is equal to A magnitude of A, magnitude of B. No need to put dot or cross because they are product of magnitude. But here in the left side I should put a dot symbol because it is dot product. I told you the beginning time. So A dot B is equal to AB cos 180. What is cos of 180? Minus 1. So this is equal to minus 1 into AB. So minus AB. So that I have written here. Dot product two anti-parallel vectors is negative of the product of magnitude of the vectors. Negative of the product of the magnitude of the products. Is that clear? Now we go for the multiplication or the dot product of two vectors in their component forms. Let me erase this thing, then I will go for the component form. And this is very interesting. Now this is your, I think 7, right? Property number 7. Okay. So let me write this as a 7th one. So what we will discuss about the 7th? Dot product of two vectors. Dot product of two vectors. Dot product of two vectors in terms of their components. In terms of their components. Already we discussed about the component form, how we write the vectors, right? So let I have a vector A. Suppose A has the components AX along x-axis, AY along y-axis, AZ along z-axis. So how I can write this vector A? I can write this as AX magnitude along x-axis multiplied with the unit vector I kept. This is the component of a along x-axis in vector form. This is the magnitude. Similarly, along y-axis ay jk, along z-axis az kk. That already you know that how to write the vector in its rectangular component form. Similarly, b is another vector where bx I cap along x-axis, by j cap along z-axis, bz k cap along z-axis. This is given to me because I am finding the dot product of two vectors in terms of their component, and the vectors are given in their component form. So I am using this thing. Now my point is, if I do this a dot b, what I will do? For the result I will get in component forms. So let us write according to this one, ax I cap, ay j cap plus az k cap. This is vector A. Then put the dot, and that dot should be prominent. Put the dot in between the two vectors. If there is no symbol dot or cross between the two vectors, they are meaningless. There is no use in physics. So this is a vector because I cap, j cap, k cap are there. Yes, x, ay, az are the magnitudes, but it is multiplied with a vector. So this is a vector, this is a vector, this is a vector. Sum of the three vectors is a vector. So plot dot bx I cap plus by j cap plus bz k cap. This is the vector b. Now we make the dot product. So when you make the dot product or when you make the products, what are you doing? Each term of this one multiplied with each one. So this, according to this one, I can write this is equal to, obviously this LF is n dot b is equal to, let me multiply ax I cap with bx I cap. So how we write this as x bx, see what I am writing, ax I cap multiplied with bx I cap with a dot symbol. Why? Ax is a scalar, bx is a scalar, so we can write ax bx, no problem, or bx ix. Then the next part is the vector I cap is multiplied with I cap with a dot symbol. So I will write like this. This is important. Ax bx I cap dot I cap. Similarly, the next term will be ax I cap multiplied with by j cap. Means ax I cap dot product by j cap. So ax by let me write scalars. Then I will do I cap dot j cap. Then plus ax bj. It is multiplied with this one, I cap dot k cap. This is important. I cap dot k cap. Then next part, then what I will do? Ay j cap multiplied with each one. Ay bx. Let me allow to write. Are you getting? And you can also write like this, j cap dot I cap. Or you are free to write I cap dot j cap. Both are same thing. But there should be a dot symbol. Plus ay by j cap dot j cap dot j cap plus ay bj j cap dot k cap plus az bx k cap dot I cap plus az by k cap dot j cap plus az bj k cap dot k cap. Can you write like this? Right? Is that correct? Now go to the dot product of I cap and I cap, j cap and j cap, k cap and k cap. Dot product two equal vectors. What is I cap dot I cap? This is 1. And obviously the dot product two vectors is a scalar. So the dot product this vector dot product is a scalar. So the final result will be a scalar. Now go to this one. I cap dot I cap. Let me put it. What is this one? I cap dot I cap? 1. So ax bx multiplied with 1. This will give you what? The result will be, let me write here, a dot b is equal to first term ax dx. Clear? Then plus ax by I cap dot j cap. Recall I cap dot j cap, I cap dot j cap the dot product of two rectangular unit vectors which are mutually perpendicular. I and j are perpendicular. Theta is 90. So this is 0. I dot k 0. I is also perpendicular to k. I j k. I is perpendicular to k. I is perpendicular to j. J is perpendicular to k, and j is perpendicular to I. So this is also 0. Then j dot I. If I dot is 0, j dot I is also 0. So this is also 0. Then j dot j 1. So what I am writing next? Ay by into 1. So this will give me a 1. This I j dot j. Then j cap dot k 0. K dot I 0. K dot j 0. K dot k 1. So the next term is plus aj bj. So what is the result? A dot b is equal to, in component form, let me write here, if this is given, then A dot b, let me write here, the result is A dot b in component form, A dot b is equal to ax dx plus ay dy plus az bz. Remember, we will use this one. What I am doing here, when you do all these things, what is got the final result? I cap, the coefficient of I cap of A and coefficient of I cap of B, they are multiplied, J and multiplied, and K is multiplied. The other terms are 0. So this is, remember, this is a very important result in the terms of rectangular components. Okay. Now we go for the direction. So next we will find the angle between two vectors. Next we will go for the 8th one. Let me take this 8th one is direction of two vectors. Means this theta. What is this theta? How you find this theta? If I know A and B. If I know A and B, how to find this theta? Right? So next is the direction of two angle between, let me write like this, direction or angle between two vectors. Let me write this as angle between two vectors. How to find this? Angle between two vectors. As you know, A dot B is equal to AB cos theta. Suppose I will ask you what is the angle between these two vectors, that is theta. So cos theta, we can write this is equal to A dot B divided by magnitude of A and magnitude of B multiplied. Isn't it? So this is your cos theta. So if I ask you what is theta, then you will write cos inverse. This is cos inverse of A dot B divided by AB. And obviously this is a scalar. A dot B is a scalar, A is a scalar, B is a scalar, so that division is possible. But vector division is not possible. Don't put vectors over here, that it is wrong, it is meaningless. Okay? Now, if it is in vector form, so in component form, if I ask you, write in component. If in component form, if you write theta is equal to, we can write cos inverse as it is. What is A dot B? If A has components, right now we will A dot B, I can write this as Ax dx plus ay dy plus az dz. Right now I have done this one. There A is equal to, I have taken what? A is equal to ax I cap, ay j cap, az k cap. Then B is equal to bx I cap, by j cap, bz k cap. Now next important part. What is this A? Magnitude of A. If it is in component form, this is one form in direct angle. If it is in component form, if it is given in component form, then what is the magnitude of A? What is the magnitude of A? If a vector is given like that, to know the magnitude, in the last video we have discussed about this thing. So I told that go through the video thoroughly. So A magnitude, if it is a component form, magnitude of A, or you can write this is a square root of, tell me, ax square plus ay square, az square. What is the magnitude of B? Square root of, in component form, bx square, by square, bz square, summation. So in that way you can write here A is equal to square root of ax square, ay square, az square multiplied, you can see by multiplication, square root of bx square, by square plus bz square, like this. So cos inverse of this thing in rectangular component forms. Is that clear? Clear? Now we go for the next one, ninth one. The ninth one is that. So let me ask you, the projection of a vector, projection of a vector, the projection of a vector along another vector, along another vector. With the magnitude only, we will discuss about the magnitude. Suppose I have given, suppose this is the vector B is given to me, this is the vector B, and there is another vector A. A is a vector. If I ask you, then what is the projection of a vector A along the other vector B? So what do you mean by projection? To know the projection, what is the point is that, the meaning is that, what is the magnitude of vector A along B? As you know, if we have a vector, suppose I have a vector and the vector is acting along this direction, it has the effect in all directions. It has the effect on all directions. That is the components. When you are doing the components, what are you doing? You are finding the effect of the vector in different directions. That is the component. I am applying a force in this direction. I am applying a force in this direction. Means the force is not along this direction. It has no only effect on this direction. It has some effect to this one. It has some effect to this one. It has some effect to this one. If I apply like this, it has an effect to this one. So I get pain here. So I get pain here. So it has an effect. Like that. A is the vector, it has the effect in all directions, but in this case, the projection of vector along this vector is, what is the projection of A along B? So to do that, generally what we will do? We will draw a perpendicular, let me put this is that, draw a perpendicular like this. So this is your L. And let this angle is obviously theta. Then what is the component of A along this B, along this OB? ON, what is this ON? Let tell me, what is this ON? ON is equal to what? A component of A along this direction. What is this ON? A cos theta. A cos theta. Magnitude. What is this magnitude? ON. This is A cos theta. Draw a perpendicular. Where it means to be, this is the magnitude A cos theta. My point is to, what is the projection of the vector A along the vector B means I have to find out ON, which is A cos theta. I have to find the, right, A cos theta. So to know this A cos theta, so let me write the projection as P, which is equal to ON. For suppose in this case ON is equal to, what is that? A cos theta. What is that? I will find out. A cos theta. So what I will write is A cos theta. As you know, this is equal to magnitude of A. What is cos theta? Right now we have found that A dot B by AB. Magnitude of A and magnitude of B. So this A magnitude and magnitude cancel each other. So ON, that projection is equal to A dot B by B. magnitude of B. A dot B by B. Done. What I will write here? Or I can write this projection O and B, but I can write A dot. Then can we write B vector divide by magnitude of B? This is a scalar. You can divide this with A or you divide with B. So B dot B. So this can be written as A vector dot the vector divided by its magnitude. What is this one? A vector. Now tell me. A vector B can be written as, it has both parts, magnitude, magnitude. Direction, which vector has a direction along B? This gives magnitude, this gives direction. Multiply this gives the vector. So if I ask you what is B, B by B, this B will come to this side. This can be written as what? BK. Right? So what is the result here? The projection OM is equal to A dot BK. Means vector A, this is equal to vector A. Means the vector whose projection you have to calculate, that vector, right? That vector A and unit vector in the direction of which one? B vector. B cap means unit vector in the direction of B. Clear? Similarly, if I ask you, what is the projection of B along the direction of A? Reverse. Projection of B along A. Projection of B along A. Then what you will do? Now you draw a perpendicular from B upon A. Draw a perpendicular from B upon A like this. This is the perpendicular. Suppose this is M. What is OL? If B is the vector, if this angle theta, what is this OL? Now forget this one. OL. Okay, this is the vector A. If B is the vector, draw a perpendicular. Let this meet OM. We will find what? B is the vector. Then what is the component of B along this one? Along OM. OM is equal to B cos theta. So projection of B along A means B cos theta. Similarly, to do this one, you will get vector B dot A cap. The unit vector vector B. Same. Projection of A along B means A vector dot B cap, B vector dot A cap. You can do like this. Clear? Then, if I will ask you, the vector component of B along the direction of A. What is the vector component of B? Next, vector component of B along the direction of A. The same question if I ask you, vector component of B along the direction of A. Vector component of a vector component of a vector, right? Vector component of a vector along the direction or parallel along the direction of another vector. Ninth one, we have discussed about the scalar part. So now the same, do the same thing. Vector A and let this is the vector B. And this angle is theta. To make it more clear, so I put the arrow mark here, you can put at the top also. So here I will ask you, vector component of the vector B along the direction of vector A. Means do the same. So this is the line. So let this is OM. So as you know, this is B cos theta. This is the magnitude, but I am asking you what is the vector component. Means let us consider that B has a along this A vector. So we can write in the component form like this. Perpendicular. B is a vector. Along this it is A. Sorry. Along this it is Bx, and here it is By. If it is x, so Bx and By. In vector form, B is equal to Bx plus By. we are writing b vector is equal to bx vector plus by vector, or you can write this as if this is your x-axis, this is y-axis or perpendicular. You are writing bx I cap plus by j cap. That you are writing. From there we got that. What is b along the direction of a means I want to find this bx vector. So to know this one, bx vector is equal to what I can write here? Means obviously magnitude of bx. Magnitude of dx. Then if it is a vector dot the direction of a unit vector I have to multiply, so that means it will become a vector. So which unit vector I will multiply? I will take a unit vector along the direction of a. Which unit vector is along the direction of a? A cap. A cap. If you multiply this a cap, this is a unit vector along the direction of a. So what is this dx magnitude? That is equal to b cos theta. Already know that direction. This magnitude of dx is equal to b cos theta, and along this direction you have bx. So along the magnitude of bx is b cos theta. So this is b cos theta. B cos theta. So now put here. Now put the simple method. Cos theta is equal to what? A dot b IAB dot a cap. So b will get cancelled. This is equal to a dot b. Right? What is a cap? Vector a by magnitude of a, and already a is there. So this is equal to I can write a dot b into vector a divided by a dot a square. This is your dx. Is the vector component, and the scalar component already derived. The scalar component, and this is the vector component. Similarly, what is the vector component of a along b? What is the vector component of a along b? What will do? Vector component of a along b means suppose ax component of a along b. So let me write here ax vector component of a along b. Ax is equal to simply a dot b is there. Then in place of a here I will write b divided by b square. You can show that one. You can also show that one. Okay, a dot b by b square. So this is the vector component of a along b, right? So in this whole discussion, the product, this dot product vectors, we come across with the different properties of this dot product or the scalar product. So the whole conclusion is that when you do the dot product of vectors, then you are getting the result as a scalar. So by doing the dot product, we can make the result as a scalar. So this is the importance of this dot product, and I have given the examples where this dot product are used. To the work is the scalar, dot product to vectors, force and displacement. Okay, students, go through this video and get a clear idea about the dot products of two vectors. Then in the next video we will go for the other vector product, that is the cross product of two vectors. Means there should be a cross symbol between the two vectors. And now onwards we got that idea that if there are two vectors are there and you are doing the multiplication, then you should have a symbol in between the two vectors. In between the two vectors you should put a symbol, otherwise it has no meaning. Okay students, thank you.